once again, welcome back to the online tutor. So in this tutorial, I'm going to discuss the frictions lesson, the third tutorial. So actually, I have gave you some examples to be done as a homework, right? So now it's time to discuss the question. Okay, so we'll see. A uniform rod of length A and weight W pressed in a vertical plane inside a fixed rough hemisphere ball of radius A. The rod is limited in equilibrium, incline an angle theta to the horizontal, and the coefficient of friction is mu. Mu is less than root 3. Show that the reaction at the lower end of the rod is W cos theta over root 3 minus mu. Hence show that the tan theta 4 mu over 3 mu is square. Okay, the first of all, you have to find the reaction of the lower end. How to find this? Okay, this is my hemispherical ball, and this is rod. This is the origin of the hemisphere, and all the reactions are passing through the origin, S and R. This friction value is F1 dash. So because it's try to move the down, right? Here it's F2 dash up because the rod is trying to move to the down. So the friction is always opposite. So this is actually the dotted line mean my reaction of the friction and the resultant. The resultant of the friction and the reaction. On all here, it's concurrent at a particular point of that vertical line W. So I assume the W is here. It's mid of the AB rod, and the length also given them. The length is A of the rod. AB rod. So the rod incline theta angle with horizontal. So now I'm taking a moment around B. This length are same, no? 60 degree, 60 degree, 60 degree. So when you construct a perpendicular line, so it's always a sine 60. The perpendicular line of the S this is mu r. Mu r A sine 30 degree. What about W? W into the perpendicular line distance. So actually the distance is a by 2, no? The angle is theta. A by 2 cos theta. All a's are cancelled. So I'm going to substitute the value to subject R. Here mu R half. R is in the one side, the weight is in the other side. Okay, actually you can see now the R can be taken out. Root 3 minus mu equal W cos theta. Then R equal W cos theta over root 3 minus mu. So that is what we got as R. The next thing is, children, to find the other reaction of the upper end, right? To find the reaction at the upper end. So this is the reaction of the lower end. And actually I think hope you have to get another moment around A, right, to get the reaction of the upper end. So we need S. I'm taking moment around A, anti-clockwise direction. So the light is same, right? S into A sine 60 degree. This distance, it's A. How to find that angle? It's 30. Because of its 90 degree, no? The friction and the reaction make 90 degree. Mu S A. It's cos 30 sine 30. This is sine 30. And what about W? The W is rotating our other way around. It's W into A by 2 cos theta equals 0. Okay, now you can subject S, right? Actually I made some mistakes, right? So mu S is rotating other direction, right? It's plus. So the S will be mu W cos theta over mu root 3 plus mu. So comparing with the R, so the only difference is here the denominator we have plus now, the R has minus. That's the only thing. Okay, so successfully we found the other reactions as well. Now we have S and R both. So normally the previous sums, what we did, we got two component and one moment, no? But here we got two moments, right? Okay, so R and S also now okay. right? So the next thing is how to find the other one, the other answer. So you can see we have to find the tan theta. To get the tan theta, I decide to take the moment around O, another moment, right? So O, mu s, it's rotating our direction, mu r also rotating our anti-clockwise direction, doesn't matter, mu s into A, mu r into A. But W, what happened to the W? We just need to calculate the perpendicular distance from the W to O. So the that line is horizontal, our weight line is vertical, they meet at perpendicular way, like in this way, but how to calculate that perpendicular distance, that's the important thing. So I'm just removing this diagram, I'm drawing another diagram including only our main data, right? Because it's difficult to find the perpendicular distance like the previous diagram, right? So this is again my diagram. Here we are R and S. The friction also should be there. F2 dash, F1 dash. So the objective is finding the perpendicular distance of the weight. This is 60 degree. Okay, this is my perpendicular. X bar. Okay, now what happened, this is equilateral triangle, no? When you construct a perpendicular line to the AB line, right? So it's meet at the center of gravity of the rod. The all are same distance, A by 2, the one, I mean the midpoint to the midpoint, right? So that red color distance can be taken with A sine 60. A sine 60. Then the other, the right angle triangle. So this is 90 minus theta, no? And now vertically opposite, this is 90 minus theta, and that is theta. Then you can see my G, that right angle triangle. So X bar can be taken with A sine 60 into sine theta. This is X bar, right? X bar mean root 3A over 2 sine theta. Now we can substitute the value of S and R. The only difference is negative and positive, no? So we can take a common denominator. So actually now we are in a close area, right? So because the answer is very close, all W's are getting cancelled, so we can find the tan theta. So what we need tan theta, no? So I'm taking, so mu is also outside, I'm taking common denominator, and we can actually divide all by cos theta, then 1 over mu root 3 minus mu 1 over root 3 plus mu equal root 3 by 2 tan theta divided by cos theta. Root 3 plus mu, root 3 minus mu, mu also cancelled, 2 minus mu, 3 minus mu squared, So this is 4 root 3 over root 3. Put mu. So answer is now okay, right? It's mu. So hopefully it's 4 mu over 1 3 minus mu square. Alright, and the value of tan theta. So it's really cool. Actually it's not hard, right? So but the difference is we got 3 moments to find the all answers. 3 moments, no components, only 3 moments, because it's easy to take a moment around O, A, B likewise, right? So see, the only thing is you have to prepare the perpendicular distance, that's all. Right, children. Now we can move to the another sum. Okay, a uniform right circular cylinder rests horizontally upon 2 equal rough inclined planes which are fixed in opposite senses at an angle alpha to the horizontal. The axis of the cylinder being parallel to the line of intersection of the plane. A couple of moment m is applied to the cylinder tending to turn it about its axis. If w is the weight of the cylinder, a its radius, and lambda the angle of friction. Show that when the cylinder is about slip m, half w a sec alpha into sine 2 lambda. So we just need to find the moment, right? So that couple value m in terms of alpha and lambda. Okay, we'll see how to find this. So first of all, I'm going to draw the diagram. So hope you all have draw it, right? Before watching the that part, so you just need to draw it, right? So I'm also helping you to do the sum, right? First of all, you have to try it, right? Otherwise, how can we study the mathematics? Okay, this is my sphere. So both the sphere is in the two inclined planes, right? So the inclined planes are make same angle alpha. So obviously it should be symmetric through the the vertical line through the origin. Right. You just need some good diagram, right? Otherwise, how can we draw the forces, right? Okay. So it's symmetric, right? Okay, let's draw the weight, reactions all. This is the reaction. This is another reaction. And this is the couple value. So I assume it is anti-clockwise direction. So someone can think it's the other way around, doesn't matter. But once you put the clockwise direction, the friction is going up because it's trying to move the down. The friction is always opposite. Then this is down again. This is weight, right? So weight is W. It's passing through the foot of the two inclined lines, the intersection point of the two inclined lines. These are mu r, and here we are mu s, f2 dash mu s. So I hope to take the moment. So what we just need to calculate that the answer, that answer it's m equals something, no? So we don't have s r, right? So it should be all mu r, right? All should be cancelled off. So I think it's better to take two components and one moment. So I'm just taking the couple of clockwise direction. It's mu s into a, mu r into a, same direction, both are right, and it's equal to the m, capital M, right? Because origin O, we don't have more forces. R and S are passing through the origin. No, it's not coming. Only mu R and mu S comes. Okay, with the capital M. So I shift the diagram to the corner because I just need some spaces. No, right. Then we'll see how to take the components, the horizontal and vertical components. So this obviously alpha, no, both alpha, it's symmetric, and R plus S cos alpha plus this is again alpha, no, sorry, alpha it's other way, it's 90 minus alpha, and f1 dash minus f2 dash, this is 90 minus alpha, and it's sin alpha, and equal to W. So actually the couple value is not come into the equations. The couple is two parallel forces, no, it's only moment. So what about the horizontal component? We can find it is minus R, so it's sin alpha obviously. The vertical one is cos alpha now. The horizontal one should be sin alpha now. This is alpha again, and f1, but actually f1 and f2 both are in same direction. It's cos alpha. And I'm just taking the moment, the rounds of the previous results that we have found, right? Actually you can substitute f1 dash and f2 dash as a mu r and mu s respectively, mu s and mu r respectively. This is my third equation, right? So right now we have three relations with S, R and M. So we just need to find the capital M, and both S and R should be replaced by the previous two equations. So what I did, I substitute f dash r mu, right, with the mu terms, mu r and mu s. So this is my other relation, right? So I construct all three equations, right? So actually we can change the sign of S and R. I put minus to the corner, right? Then what I'm going to do, I'm just multiplying the second equation by mu and added to first equation, because if you add it in this way, the r minus s mu sine, so mu r minus s sine alpha, it's getting cancelled, no? And r plus s cos alpha and mu squared r plus s cos alpha, it's only remain. So we can pull r plus s out now. r plus s cos alpha 1 plus mu square. It's w. And r plus s equal w over cos alpha 1 plus mu square. So what is mu? Mu is tan square lambda, right? So I told you in the theory lesson, watch the first video. So I told you the mu equal tan lambda always. 1 plus tan square lambda is under the trigonometric, it's x squared lambda. So it's going up with the cos squared lambda. Right, so hope now we can substitute the r plus s value to the main equation, capital M equation, to determine the capital M in terms of only alphas and lambdas. The capital M, so I'm substitute the r plus s. So mu mean tan lambda, no, sin lambda or cos lambda. W cos alpha squared cos squared lambda. Cos lambda is cancelled. 1 cos lambda is cancelled. So now here we are. So we got sin lambda cos lambda over cos alpha. So actually the answer, we had 2 sin 2 lambda, no? So I'm just putting 2 and 2 for the both numerator and denominator. The numerator will getting sin 2 lambda half sec alpha, it's of course coming up, and sin 2 lambda. So this is the answer, capital M, the couple value. Actually it's easy, right? So what I did, I draw the diagram and I got the components and the one couple, one moment, right? Right, children. Now I think you might okay now. So this is 2019 A-level paper question, so you can try yourself now, right? So it's actually structure essay question is very easy, right? Okay, right, children. So hope you have enjoyed with my friction lessons. So I did 3 tutorials, so please watch it again, right? So and try more questions, right? So past paper questions and all. And I think now you feel better about the friction lesson. This is actually easy. It's under the directly it's connect with the theories, right? The theory you should understand. Can you remember the inequality one? The inequality one is very useful. Okay, so normally these days they ask the inequalities in the friction lessons, right? So inequality mean if it is equilibrium is f dash less than or equal mu r. That's all. Right. Okay. Then friction lesson is directly connected to the so many static lessons. So which connected to the center of gravity, which connected to the normal equilibrium, right? We can connect friction lessons to with the various lessons, right? So actually jointed dots can be come with the friction lesson, right? So in A-level combined mathematics we have the friction lesson with the static, right, not the dynamic. But dynamic is with the work power energy, actually the friction. So it's resistant force as a resistant force. So we know the friction එක resistant force එකක් විදිහට අපි සලකන්නේ. ඉතින් friction එක lesson එකටත් අපිට use වෙනවා. හරි, එහෙනම් thank you very much for watching my videos, right? And hope the next video session I will describe the work power energy, right? So thank you very much for being with us and have a nice day. Goodbye.